What's going on, guys? Cody from Southeast Softwash. Today we're going to be talking about how to build a blend manifold. We've got a few examples here behind us. So this is a GF blend manifold. This one's going to be a chemline setup. This is ours, a batch buster setup. It's a brand new, the only soft wash metering valve made for soft washing. So to take these valves and these components and turn them into something useful, we call that thing a blend manifold. Some people brand them as a proportioner, different names for it, but the concept is the same. We're taking three different chemicals, water, soap, and SH, and we're gonna lay this thing out. There are some tips, some tricks. You wanna lay it out a certain way. So without any further ado, let's jump into it. Hey, before we get to how to build a blend manifold, I want to let you guys know we just finished our course. It's called How to Build a Rig. It's going to be down in the comments, down in the description section. There'll be a link to take you to it. But we get a ton of phone calls of guys that they want to get into the business. They just simply cannot afford a turnkey system, and they're wanting us to help them out. Well, I figured the best way to help you out is just to make a course, give you guys all the tips and tricks of how to build your own system. That way we're not on the phone trying to walk you through it. We just can't man the phones that much anyway. So if you're interested in taking from start to finish, frame, trailer, skid, no matter what it is, we're going to go through wiring, plumbing, material selection, layout, design, pressure washing, soft washing, all the nuts and bolts, literally the nuts and bolts of putting a system together. And we've built over 1,500 at this point. There's a lot of them all around the world. So if you guys want to learn the tips from the pros at Southeast, grab the course down below. I'll see you in the course. All right, guys, so we're here at the workbench. We're gonna assemble a blend manifold like we looked at up front in the office. So a couple of valves out there as options. We've got GF valves. We've used those for years. We've got chemline valves. We also like the chemline valves. Some guys use a Hayward metering valve. It's a flow control valve. And there's a Shy valve out there. So multiple options to choose from. This is our valve. We just rolled this out to the market. It's the first soft wash specific metering valve. Some really cool features about this valve. Before we get into this, I want to take you guys over to a rig and show you kind of what a blend manifold looks like. We've got a completed one here, but let's take a little trip over to the rig up here on the lift table, show you the layout and how it's going to work on the system. Okay, so we're over here on a Alumimax Pro. This one's in progress, and we've got a blend manifold set up here on the system. So no tank in the middle. We haven't dropped that tank in yet. That's gonna be the bleach tank. The back tank is our water tank, and this tank here on the floor will go in this pocket and become our soap tank. The orientation here of how you build your blend manifold, it kind of matters a little bit. If you build it wrong, it's not the end of the world. It will still work just fine, but there is a little bit of reasoning here as to how we lay the system out. So we like to put our bleach line as the far right-hand leg of the manifold. The reason we do that is when we get finished with a job, we're gonna cut our bleach off, our soap off, leave our water on, all the way left is on, and we're gonna purge the system. So what we're really trying to do is to flush out our pump, flush out our hose reel, flush out all those components. If you build it this way, and this closest line to your outlet port is your bleach valve, then it's basically going to evacuate this check valve as you're doing your flush out procedure, and the water is flowing from the farthest point. So it's basically flowing past these other two inlets, and it will sort of help to flush out as much of the manifold as possible. So you want your water to be the furthest point away from the outlet going here to the pump. That way it's at least helping to flush out the majority of the manifold. If we were to put this as the water, well, these other two lines are really going to stay stagnant. It'll still suck the fluid out, but we want to have water behind that to flush the entirety of the manifold out as much as possible. Another thing we do is we orientate the valves. We have to flip-flop them to make everything fit so that the handles don't hit each other. Now, we like to do it like this. Bleach, water, and surfactant. Surfactant's always in the middle, and we lower the surfactant metering valve and put the check valve on top. On these other two, it's exactly opposite of that. We've got our metering valves on top and our check valves on the bottom. Does not matter on the water side, but it does matter on the bleach. Again, when we're doing our flush out procedure, this check valve is gonna get cleaned out because it's down here below our metering valve. So if it was in the opposite orientation, like we'll take a look at the soap valve here, when we're flushing out, we're gonna kill the soap line. So that means it's blocked here, and this check valve is never gonna get cleaned out or flushed out or evacuated. Doesn't matter, it's just soapy water. We don't want that on the bleach. We want the check valve down here so that it can be evacuated and get that SH out. Some guys that build manifolds, other companies, they'll put a secondary flush out line here to basically flush this entire leg out. You don't need that. Our Softwash metering valve, we've tested it to 100,000 gallons of SH, just continuous running. So this valve does not care about bleach. It is totally impervious to bleach. And the check valve here, we don't really feel like an extra leg looping back to flush out that check valve is worth it. It's about a $15 part. They use a Hastelloy spring. So if you guys are buying these parts and building your own, try to get the one with a Hastelloy spring. That is a super corrosion resistant alloy. So these last about 18 months, 2 years anyway. It's, you know, 10 to 15 bucks. Change it out every 2 years. It's not a big deal. I don't want to add another step here for a $1 per month savings, right? It's just not worth it. We don't feel like we need that. And we've built a couple thousand rigs, and we can just tell you, you don't need that. So lay it out like this. It's going to be the best way to lay it out. Soap in the middle, water and bleach on the right. If you kind of copy this layout, it's the best one that we found and we've built. I couldn't tell you how many, several thousand manifolds. We sell these on the website as well. So let's go back over to the workbench and show you how to put one together. Okay, so we've got some components here that we're gonna need. Obviously, you're gonna need a metering valve. Batch buster metering valve is the best. You'll notice on ours, we've got a red union and a black union coupler here. Reason is, our metering valve's the only one of its kind that will do this. It can become a 1-inch setup, like a 24-volt gas-powered system, a high-flow booster pump, and you utilize your 1-inch red couplers for that big barb high-flow system. If you're only running, say, a 5 or 7 gallon a minute 12-volt, you're going to use the black couplers, which is a 1/2 inch. So it's buying a batch buster system, guys. It's really cool because you're kind of getting two systems in one. Let's say you built it like we're about to show you here for a 12-volt, and then a year from now you wanted to run something bigger, anything bigger in the high flow range. All you got to do is swap out some components and basically upgrade your manifold to a higher flow system. You don't have to buy all new valves, and that is the expensive part of this. So you're probably going to save close to $1,000 when it's all said and done. You're sort of getting two valves in one. So that's what we're going to be using, our valve obviously for this layout. So we've got 3 valves here. Soap will be in the middle, bleach, and water. Now you ask, why do you need a valve for the water? You want to make sure you get uniform flow through the system. That way your ratios are not going to be skewed when you're doing your application. If we just put a regular on-off ball valve here, it wouldn't work right. You get a ton of flow on this side and you get very minimal flow on the other side. So we want to have a metering valve for all 3 lines. That way our ratios are accurate. So we've got our 3 valves. Now we've got this is an aluminum, almost said stainless steel. This is an aluminum mixing block. We make these. You can also use street elbows and couplers. We've got a cabinet back here and full of banjo parts, right? So you could take a bunch of parts like this and make the same basic idea as this block here, which gives you your three ports for 3 lines and the outgoing to the pump. Nothing wrong with that. We just started using the blocks because they're better, they look better, they're more robust, and we just eliminated several connections by having it just 1-piece block. So by doing it this way, it's a little more robust. It gives you some mounting points here. These particular ones we use in-house have mounting holes in them. Here's another variant of that, poly block. It's got 3 mounting points as well. Aluminum is corrosion resistant. Obviously the poly is corrosion resistant as well. So this will go on a really big high flow system, 1-inch ports all the way around. So let's go back here and look. We've got our block or your parts, whatever you want to do. You're going to have some nipples. These are 1/2 to 1/2, so that will connect here to here. You're going to have some check valves. This is very important. We've seen guys build an entire manifold and didn't put any check valves in the system. That ain't going to work because now you're going to cross-contaminate your tanks on the first time you use it. So you've got to have check valves, also known as a one-way valve. You'll notice these have a directional arrow. That directional arrow means it only flows that away, and those need to be pointed down towards the direction of flow. So we'll need 3 of those. We'll need some barbs. And again, this is going to become a 1/2 inch setup. If you're using a bigger setup like this one, you'll notice we use 3/4 inch, check valve here and a 1/2 inch on the soap line. So just make sure you size your check valve according to what that leg of the manifold needs to be. It wouldn't make any sense to have high flow valve, high flow barb, and then neck it back down to a small check valve here. We want a lot of flow on this line, a lot of flow on this line. The soap is an additive, so it's not as important. You can kind of play with the soap, the surfactant valve a little bit. because we can mix our surfactant stronger or weaker depending on what we're going to do. So that one's not the critical one. We want to make sure the water and our chemical line are the ones we're getting the most flow out of, if that's the type of system you're building. All right, so we've got our poly block, our aluminum block, or our fittings from Banjo, or whatever you want to do. First thing you're going to need, guys, is some True Blue sealant. We like to use this stuff. Do not use Teflon tape. You can make it work. It ain't right. Use some liquid pipe dope. This stuff is a soft set, and it's not going to harden up on you. So first of all, we're going to get a barb. Going to make our Legos connect together. I only like to coat, say, the first 2 or 3, maybe 4 threads on this this barb. The reason is it's going to make a big mess if I don't. You will need an adjustable wrench, which I've got one somewhere over here. Yeah, we got one right there. This is way overkill, but we'll use that. So we're going to screw that in, basically copy and paste here and here. All right, so we're going to get 3 of those True Blued down and run them down until they get tight. That's hand tight. Same thing here, and then just run them down with your wrench. It doesn't matter what you do from this point, as far as I'll usually go ahead and throw my outlet barb on as well. This will be your barb going to your pump. Same thing, True Blue on the first few rounds of threads. The reason we don't want to True Blue the entire pile of threads here is it's just going to be really messy. So we run some True Blue. I'm sure all the expert plumbers in the comments are going to tell me how I'm doing it wrong, but since I've built more of these than you have, I'm going to keep doing it our way. This is just how we like to do it. Gets a good seal, and when you run that in, it's going to make a nice clean bead. It's not going to look sloppy. So let's, my wrench is crusty. It's got True Blue all over it. Run that joker in. You can see it kind of creates a good clean bead around that outlet barb. Okay, so that'll be going to our pump. We'll slide a hose over that and put a hose clamp right here in this area. So we're going to get our 3 barbs set up. From that point, we're going to add our check valves here, and then on the middle line, because we're trying to lay it out like this, we will add our our surfactant metering valve. So I'll usually go ahead and build the surfactant valve. You could actually build the leg up and then just screw the entire assembly down onto here. But we're going to True Blue this part as well and screw this on. Guys, a little trick. You can, if it sort of gets in the way, you can take this off and put that on if it's easier to do that way, and then reattach with you'd leave that. This would be below. Then you can just bring your union back up and couple it apart. That also comes in handy if you ever have to do any work on them. You can break the union loose. You don't have to disassemble the entire manifold to get that off. So we're gonna lay it out like we want it. That would go there, and then we would have another nipple there, 1/2 by 1/2 in this case. Then we would have our check valve, making sure that the arrow is pointed in the right direction. And then on our surfactant, you could use a 3/8, a 1/4 inch. It just depends on really your overall system that you're building. If I was going to build anything in that gas powered system range, I'd probably bump this up to a 3/8, because a 1/4 inch is going to be too small for the other 2 lines amount of flow. Doesn't really matter, but you want to sort of size the surfactant to what the other 2 legs are going to be. All right, so there's our surfactant leg. Again, True Blue all these fittings up, assemble. On the other 2 sides, it's the exact same thing, just a different orientation. So you got block, nipples, check valves, barb to there. Again, all this would be True Blued together, there to there, and a barb going out. Now you can use a straight barb, but we've also got 90s over here in the cabinet. Again, it just sort of depends on how your system needs to be laid out. You can put a 90 in here as well and bring that liquid in. The 1/4 inch is real flexible, so we can bring that and curl it without it getting a kink. So use 90s, use straight, whatever you need. But when you get done putting all this stuff together, it's kind of going to go from a pile of parts to something like this to something like this. Again, all True Blued. The beautiful thing about this, guys, is it lets us meter our chemicals and change ratios on the fly by manipulating your valves, but you've also got to make sure all that stuff stays airtight. It can't have any air leaks in it, or it's going to destroy your pump's ability to prime. So our valves have mounting points on the back. These little metric bolts going here and we mount them up. So it's really secure when you put 6 bolts in here. And if you're using a block with mounting holes, you can also mount the block down as well. These from us will take a 1024, just a long bolt. We'll put a lock, like a nylon lock nut on there. So it's all really rigid. And guys, we still recommend about once a year, maybe every 18 months, to just take this thing apart, clean it up, re-true blue everything and put it back together. We tell guys that and it blows their mind. They think that they build this one time and they're good forever. Theoretically, yes, but you're bouncing down the road, you're traveling day in and day out, temperature fluctuations. So if you get an air leak, the good thing is it's all disassemblable. This is not a glue, it's just a pipe dope. So you can take it apart, clean it up, put it back together. Guys, the Batch Buster blend manifold system is a one and done system. If you grow out of the 1/2 inch variant, you want to beef up to something like this, again, you just change your coupler kit out, off you go. That's how to build a blend manifold. That's all you need: adjustable wrench, fittings, parts, and some true blue. In about 15 minutes, you can have your own blend manifold. Or if you want to buy one, links are down below. If you want to get some valves, links are down below. We'll see you guys in the next video.